Now we're going to make an adjacency matrix. It sounds complicated, but it's really not. On this particular one, all of my edges are labeled. I'm going to actually erase, I'm just writing over them with white, my edges only because it makes it a little bit more complex to see the actual graph. Again, I'm going to do the same thing over here just so that I don't have to split my efforts in looking for what it is that I'm finding. Okay, so here I have a graph. Now this is more complex than ones that we've been looking at because it does have parallel edges, it's got loops, all that kind of thing. When I have something like a loop, that means it goes out of vertex 1 and into vertex 1. So the way that we would read that is it goes out of vertex 1 and into vertex 1. And so there would be a 1 here. Oh, goodness gracious, didn't mean for it to be that big. There would be a 1 there to signify that there is a loop. And then you can do the same thing diagonally for all of your vertex 2 going in and out and vertex 3 going in and out. So let's take a look at vertex 2. Vertex 2 also has a loop there. So that means there's a 1 on V2, V2. And then I look at vertex 3 and there is not a loop there. So I'm going to put a 0 there. I always, for some reason, just do my diagonals first. It seems to make it a little bit cleaner. All right, now I'm going to look at V1. And I'll tell you my cheat code is I kind of go in and look at where it says in, that would be my columns. So I would look at V1 and I want to see what goes into V1 and then I would put those values here. And then I'm going to look at what goes into V2 and what goes into V3. So what goes into V2, I see 2 arrows. I see one from V3 and I see one coming in from V2. So one from V3 and one from V2. And that's it. That's all the way you do it. Now I'm going to look at V2. That's my second column. So V2 has 2 arrows going out. The only one coming in is my loop. So there's nothing coming in there from V1 and there's nothing coming in there from V3. And then I take a look at V3, which is here. And look, I have 2 arrows coming in from V2, nothing coming in from V1. So V1 is going to be a 0, but V2, because I have 2 of them coming in, that's going to give me a value of 2. So now I have all the ingredients to be able to write my matrix. If you want to go straight to writing the matrix, that's fine. I have a tendency to want to stick it in a table just so it's a little bit more organized. So 1, 0, 0. So I'm just copying the information that's here. 1, 1, 2. And 1, 0, 0. And then I put brackets on either side. And that's my matrix. All right, let's go ahead and take a look at this next one. This next one, something similar, right? So I'm going to look at any loops that I have, and it looks like I got a loop on V2 only. So V2 is going to get a 1 there. Oops, let's make it red. It's going to get a 1. V1 does not have a loop, and V3 does not have a loop. So I'm going to put zeros in there. Then I'm going to look at V1. Remember, I'm looking at my ins. I have 2 going in from V3. So 2 from V3 going into V1, nothing from V2 going in. Now I'm going to look at V2, things that are going into V2. I already have my loop, but I also have an arrow going in from V3. So that is going to be a 1. And there's nothing coming in from V2. And then over here in vertex 3, I only have 1 arrow coming in, and that's from V2. So I'm going to put a 1 there and nothing from V1. And that would be the start of my matrix. So I would write A equals and copy those numbers 0, 0, 0, 0, 1, 1. And 2, 1, 0. Okay, so now we've completed adjacency matrices for directed graphs. Come back to the next video to do undirected graphs.